So now we're going to talk about calculating the volume of three-dimensional objects. I'm going to start off talking about calculating volume for prisms. What exactly is a prism? It's basically a shape where if you cut the cross-section of the shape, each of the faces, each time you cut, you'll get an identical face reappearing. So like a Toblerone, you know, if you cut it this way each time, each piece is going to be identical. The cross sections are going to be identical. If you cut a cylinder, okay, that's going to be identical. If you cut a rectangular prism or a box, each of the faces, every time you make a cut, it's going to be identical each time. Okay, so what's not a prism? Circles aren't prisms because there's no way that you can cut a cross-section repeatedly and get the same face. Like obviously if you cut it here, the circle is going to be really small, but if you cut it there, it's going to get bigger and bigger as you move through. Also, pyramids wouldn't be a prism, and neither would cones. Cones are also not prisms because there's no way in the world you can cut it in any direction or angle where you can actually keep repeating the same face. So that's what we mean by prism. So the formula for the volume of the prism is given by the area of the face and the height of the object. So the area refers to the area of the identical face. So if it's a triangular prism, we want to know the area of the triangle because there's one at the front and there's one at the back and they're joined together. Okay. If I want to work out the volume of a cylinder, I'll work out the area of the circle, okay, the two identical faces, top and bottom, and the height of the object, which is the distance between the two identical faces. All right, so if you look onto the next page, which is your formulas, so I've given you the 6 formulas that I want you to know up there, just enlarged here for you to see. But what you can see here is that we can see that the 3 above are prisms, and the formula follows the V equals area times H rule. It's the area of the face, so in this case, if it's a rectangular prism, it's the area of the rectangle multiplied the distance between the two rectangles. So that's why we get length times width times height. Now over here for the triangle, we have base times height divided by 2 times height. So once again, it's base times height divided by 2, or half base times height is the area of the triangle, and we're going to multiply it with the height of the object. And by height of the object, I don't mean the height of the triangle, I'm talking about the height or the distance between the two identical faces, which in this case is a rectangle. So just because it's lying flat like this, the triangular height is here, but the object's height is actually the distance between the two triangles. And same with the cylinder here. What you can see here is that it's the area of the circle, which is given by pi r squared, and multiplied by the distance between the two identical circles. And that's why the H is in the capital, because it's actually the object's height, not the height, like the height of the triangle, for example, or the radius or the diameter of the circle. Okay, so that's prisms for you, and down here are the non-prisms, and they have a special formula as well, and we're going to practice using those in this lesson. So over here, what do we see? We can see that we have a triangular prism, and triangular prisms are given by the formula V equals AH, where the A, or area, is the area of the triangle, which is half base times height. And what we can see here is that the triangle's base is 2.6, so it's basically this triangle there, but I'm just inverting it. So it's 2.6, and it's got a vertical height of 23 meters. 23? No, 2.3. So 2.3. So half times 2.6 times 2.3, okay? And if you want the volume, well, I'll have to multiply it with the height of the object, and as you can see here, the height of the object is 3.2, or we can say that the height of the object is actually the distance between the two identical faces, 3.2. So we can plug it into the calculator. Half times 2.6 times 2.3 times 3.2, which equals to 9.568. Check the question, it says to 1 decimal place, so it will be 9.6. And what are the units? meters, and because it's volume, it'll be cubed. 9.6 meters cubed. All right, next one. Find the volume of the shape below. Well, we don't really know what kind of prism it is, but it is a prism because it's got two faces that are joined together, and we can cut cross sections and get the same kind of M shape here. Volume of prism is always V equals AH. Area of the two identical faces multiplied by the height or the distance between the two identical faces. Area has been given to us. We don't have to calculate it, nor do we have the formula to calculate it at the moment. So we just plug it in. Area is 32 meters squared, and we're going to multiply it by the distance between the two identical faces, which is 8.2. And so the volume of this object is going to be 32 times 32, right? Times 8.2, which is going to give us 262.4 meters cubed. That's the volume of this shape. Next one, volume of the pyramid. Well, we can always just refer back to our summary book where we'll have a set of formulas and just pluck that out. It says the volume of the pyramid is given by V equals length times width times height over 3. Now, length times width times height, it's length and width of the base and the height of the object, all divided by 3. So length and width is 30 by 30, multiplied by the height. Height of the pyramid is 40, and we're going to divide that by 3. So 30 times 40, divide by 3, 12000 meters cubed. That's this one there. Moving on very quickly, it says calculate the volume of the object to the nearest centimeter squared. Now, without even looking at our formula sheet, we know that it's considered a prism. V equals AH. Area of the identical face, the area would be given by pi r squared because it's a circle, and the distance between the two circular faces is going to be the height, okay, which is in this case 20 centimeters. What do we know? Do we know the radius? Of course we do. It's given to us. So volume is going to be pi times 15 squared times 20, and the volume of this object is going to be pi 15 squared 20, this value, and it says give it to the nearest centimeter cubed, so that just rounds to 14137 centimeters cubed. Okay. Now here is a composite object. It says find the volume of this toy correct to 1 decimal place. So we can see that this object is made up of a cone. So we need to find the formula for the volume of a cone, and we can refer back to here because it's not a prism. Should have drawn a proper cone. Okay, so the formula of the cone is V equals pi r squared times big H, which is the H, remember, is the height of the object, divide by 3. And what else do we also need? Well, we can see that at the bottom we've got a hemisphere, or half a sphere. This is a formula for a full sphere, so we're going to pluck the formula out. 4 pi r squared divided by 3, and we're only going to use half of it, or we're going to divide it by 2 because we've only got half in this scenario. So make sure you know how to manipulate these to suit the scenario that's been given to you. So let's have a look. The height of the object, actually let's focus on just the cone at the moment. The height of the cone is not 1.4. Remember, the height is only going to be from the tip of the cone down to the base of the cone. What do you reckon that's going to be? Now, if the diameter is 80, it means that the radius is going to be 40. And if the radius is 40, it will also be this distance here. So we know that the radius is 40. Therefore, the height of that cone is going to be just 1 meter. Okay, so let's put that in. Do we know the radius of the cone? Yes, we do. 80 centimeters. Well, They want the volume in meters cubed. So we're going to convert this into meters. So diameter is 80. Radius will therefore be 40. 40 centimeters converted to meters will be 0.4 meters. Happy with that? Hope so. And for this formula here, all we need to know is what the radius is, and the radius is 0.4 meters. And we can plug everything in and add them together at the end. So just looking at the cone, V equals, or volume is equal to pi times 0.4 squared times 1 over 3. Volume of the half sphere, or the hemisphere, is 4 times pi times 0.4 squared over 3. Make sure we divide it by 2 because we've only got half of it. And let's individually work them out. Do it again. Pi times 0.4 squared times 1. Why did I even do that? Divided by 3. Volume is 0.16755, and I'm writing it to several decimal places because it's not my final answer and I don't want to lose accuracy by rounding too early. Over here, let's work that out as well. So it'll be 4 pi times 0.4 squared divided by 3 divided by 2 because we've only got half of it, and that's 0.335103. I'll leave it at that. So then all we do is we add the two together to find the total volume of the object, and this is in meters cubed because we've converted everything to meters. That'll just be that value there plus 0.335103, and we get a volume of 0.5. One decimal place, well then it'll just be 0.5 meters cubed. That's that one there.